Okay. Right. So you have learned already. Let's review. Revise back. Okay, you already learned 3.1, right? And then 3.2, derive indefinite integral formula already done. Algebraic a function already done, and then how to integrate ax plus b to the power of n by using substitution method. Okay, so today we're going to learn about how to determine the equation of the curve from its gradient function. Okay, so although this is a very small part of the integration, but the question always asks in SPM. Okay, so how to determine the equation of the curve from its gradient function? So you already know if dy dx equals to function f prime x, this is called gradient function. Okay, so if I integrate, okay, both sides, right? So I will get dy equals to f prime x dy. Sorry, this is dx. Okay, so I will get y equals to fx. Okay, so this is your equation of function. All right. Okay, so meaning that we want to get the equation of the function, we just integrate, right? The gradient function. Right, so let's see how example 6. So for find the constant of integration C for the following gradient function. So dy dx equal to 3x squared minus 6x plus 4 when x equal to 3 and y equals to 5. Okay, so this is dy dx equals to 3x squared, right? 3x squared minus 6x plus 4. So we integrate dy dx, right? So, and then this one 3x squared minus 6x plus 4 dx. So you will get this part, you will get y. Okay, y is the equation of function, right? So y we call it equation of function, right? So y, so when you integrate this, you will get 3x squared plus 1 over 2 plus 1 minus 6x squared over 2, okay, 1 plus 1, and then plus 4x. And then remember you have plus c. So that's why this example 6 is to help you to get the constant c, right? So we must need to know what is the x and y value. So sometimes the question will give you the value x and y like this, or they will give you a function in the coordinate point, right? So you get, right? So we continue. You get x about 3 and then minus 3x squared plus 4x plus c. So our aim here is to get what is c lah. So now I have x equal to 3, y equals to 4, 5. Then I substitute in, so I get 5 equals to 3 cubed minus 3 times 3 squared. So 3 cubed minus 3 squared, 3 cubed lah, meaning you get 0. Then you plus 4 times 3 plus c. So 4 times 3 is 12, right? 12, and then this means c equals to 5 minus 12. So c equals to negative 7, right? So this question ends here. But if we want to get the equation of the curve, we just add another step. That is, we rewrite everything. X cubed minus 3x squared plus 4x minus 7. This is the equation of the curve, right? So this is equation of the curve. Okay, so that's been one more step, you'll get equation of the curve. If you stop at C, that's mean you only get the constant C. Right, let's see the example 7. So example 7 is not to find equation of the curve, but is to find the velocity. So I think in physics, you already know, right? S is displacement, right? So you have ds dt, you get velocity, right? So if I integrate back ds dt, right? ds dt, I'll get back s, right? So because ds dt velocity, right? So I integrate velocity, I get back displacement. So if I integrate d square s dt square, I will get acceleration, or is dv dt. I will get a. That means velocity here is v, right? So if I want to get back v, that means I dv and then a dt. So I will get back my v. All right, so a dt, right? Okay, if I want to get back my s, that means I have to integrate v with respect to t. Okay, so this one you already learned in physics, and you are going to learn this again in motion along a straight line chapter 7. Okay, okay, now we are going to do this. So meaning that apart from equation of the curve, right, it will be applied in velocity, acceleration, and displacement. Okay, now A, let's see 7A. As the given the acceleration dv dt, so dv dt, as you know, you divide it in differentiate velocity, you get acceleration. So dv dt is 3 minus 2t, and v equals to 2, and when t is equal to 1. So find the value of velocity v when t equals to 2. So, right, so we do step by step. So dv dt equals to 3 minus 2, 3. So I like to do this step, right? dv, and then 3 minus 2t. Okay, so if you integrate 1 with respect to v, you get v, right? Then you get this part, you get 3t minus 2t squared over 2 plus c. So you get, eventually you get v equals to 3t minus t squared plus c. But we want to find the value of v when t is 2. So we need to know what is c first, right? So c is given here is v equals to 2, t equals to 1. So we substitute in 2 equals to 3 times 1 minus 1 plus c. So it's c equals to 3 minus 2, 1 is 2. So you get is 0, right? So I'll move it here. So our velocity here will get t, sorry. Okay, so our velocity will get 3t minus t squared only, yeah? So 3t minus t squared only. So c is 0, okay? So the question asks you when t is, if t is 2, so t is 2, so we substitute t is 2. So v equals to 3 times 2, 6 minus 2 squared, 4. So 6 minus 4, you get 2, all right? So this is the value of v when t is 2, okay? So if you substitute straight away 2 in, you won't get the answer because the c there, right? So you get a 6 minus 4 plus c. So the c you still need to find out. Okay, let's go to B. So the same concept. Right, now is ds dt equals to 4t plus 5. Huh? And that s equal to 0 when t equals to 1. Find the value of displacement when s when t equals to 3. So we start with ds dt equals to 4t plus 5. Okay, so I like to do this. ds equals to square 4t plus 5 dt. So when you integrate this, you always get s, huh? Right? Then this one you get 4t squared over 2 plus 5t plus c. Therefore, your s is 2t squared plus 5t plus c. So when t is 1, s is 0. Therefore, 0 equals to 2 plus 5 plus c. Hence, c is negative 7. So, okay. So our s now, all right, so this one, just throw it away. Okay. Therefore, our s is 2t squared plus 5t minus 7. So when t is 3, so what is s? S is 2 times 3 squared plus 5 times 3 minus 7. All right. So if you use your calculator, you should get the answer here. All right. So I don't want to continue that. You can use your calculator to get it the answer. Right. So now we go to example 8. All right. So actually, example 7, exercise 7, sorry. Example 7, not exercise 7. This one, example 7. Okay, so actually it's a application already, but it will be more in motion along a straight line. So I introduce here first. So that you know that, okay, these two topic is related, right? All right. So now we go to example 8. Okay, so now example 8, if given a gradient function is dy dx with f prime x, so that's now already shown how to get y equal to fx. So the equation of the curve is, can it be determined by y equal to f prime, okay? Integrate f prime x dx, right? So this one you must, you have to know, and which involving a constant c that can be determined by substituting one of the point lies on the curve. Okay, so this one already I mentioned here already. Example 6 already given here, right? So let's go detail. There are A, B, C, D, E, F, and then you will do your exercise. Okay, if a gradient function is 5 minus 4x, okay, so read the question carefully. This is gradient function. Therefore, I can write dy dx equals to 5 minus 4x. Therefore, dy, integrate dy against 5 minus 4x dx. So I will get y equals to 5x minus 4x squared over 2 plus c. So you get 5x minus 2x squared plus cy. Okay, so it passes through 1, 1. So 1, 1. So I put in 1 here, 5 times 1 minus 2 times 1 squared plus c. So I will get c equals to, okay, 1, that means 1 plus 3 minus 5. So I will get c equals to negative 1. Therefore, my equation of the curve is y equal to 5x minus 2x squared minus 1. So this is my equation of the curve. So you can see here, the first step is integrate. Okay, this is first step. The second step is substitution of the point in. Then the third step, you get the equation. So first step, second step, and third step. All right. So I need to discuss this so that maybe some of the question will ask about, you will see this type of question later on. dy dx and then dx. So equals to, let's say, 2x. Okay, so what should we do here? Right, like this. Right. So this means this is actually dy. Okay, if meaning that you just cancel these two, you get dy. Right? But in reality, we don't do that. We don't cancel it. We just know that integrate dy dx with respect to dx, I will get dy. Right? Then I will get my answer y back. Okay, so this one must be careful. So that's why I like to write, when I integrate dy, I put both sides like this, then it will be not it won't be so confusing. Okay, so B, okay, this one is the same question, right? All right, so don't need to do. Okay, you can try again by yourself here. It's okay. All right, now this one number C. Okay, C, if the gradient of a normal to the curve passing through the point 40 is given by 1 over -5 minus plus 2x. Find equation of the curve. Okay, this is a gradient normal. Okay, so when a curve, okay, we find a gradient is dy dx. This is gradient of tangent. Okay, so now the question gives you gradient of normal. This is gradient of normal here, right? So this is m1, this is m2. So gradient m2, m1 times m2 equals to -1. So given you is m2, that is -1 over m1. So equivalent to -1 over, -5 plus 2x. Okay. All right. So if you put in, that means -1 over dy dx equals to 1 over -5 plus 2x. Okay. I hope I make it clear. So therefore, dy dx actually equals to -5 plus 2x, right? Equals to 2x, -2x plus 5. Okay, so this is the equation. This is the gradient function of the curve actually, because C is given you the gradient of the normal. So we need to find the gradient of the curve. All right. So next, after we get the gradient function, so okay, so gradient function. Okay, so this is gradient function or gradient of tangent. Okay, so we can find the gradient of the equation of the curve. So dy dx equals to -2x plus 5. So we integrate dy and -2x plus 5 dx with respect. So that means I get y equals to -2x squared over 2 plus 5x plus c. So if you simplify, you get y equals to -x squared plus 5x plus c. So in order to get equation of the curve, so we need to solve what is c first, right? So how to get c? Okay, you can ask yourself. So it passes through, give you a very important clue here, passes through 40. So 40, so I just put 40 here, then I substitute in. Okay, 0 equals to -4 squared plus 5 times 4 plus c. Therefore, c is, okay, -16 plus 20. So it's -16 is 4, right? But you move the 4 to the left-hand side, you get -4. Therefore, our equation of the curve is negative y equal to -x squared plus 5x minus 4. Okay? All right. So we can we can check whether this answer is correct or not. Okay, let's do dy dx on it. So we'll get -2x plus 5. Okay, so since you want to get a gradient of normal, okay, so it's m1 times m2 equals to -1. So m2 equals to -1 over m1. So this is, remember, this is m1. So we substitute in, so 1 over -2x plus 5. So If you multiply the whole thing with negative, I will get 1 over negative 5 plus 2x. So we can compare this answer and this answer. So this is correct. Huh? Okay, so this is our answer is correct. Right, now we go to D. Okay, given the gradient function of the curve is ax plus b over x cubed. So the gradient of the curve at 1, 3 is 4 and negative 1, 5 is negative 2. So actually, we just substitute in to solve what is A and B first. Okay, so this one we need simultaneous linear equation, CSLE. So we just substitute in. So substitute in 1, 3, 4. That means where is 4? 4 is gradient, right? So therefore, if I substitute in, that means our dy dx equals to ax plus b over x cubed. All right. So when at 1, 3, our dy dx is 4. So I substitute in. So 4 equals to 1, 3. So 1, 3 is, this is x, this is y. So only use x. So we put x in. So a plus b over 1. Right? So it's a plus b equals to 4. This is our equation number 1. So our equation number 2 is when I have negative 1, 5, my dy dx is negative 2. So that means negative 2 equals to negative 1. Right? So negative a plus b over negative 1 cubed. So therefore, I will get negative. This one is negative value. So negative 1 cube, you get negative 1. So you get negative. So negative, negative, you get positive. A minus b equals to negative 2. So this is equation number 2. So we solve these two. Right, so we just add this together. 1 plus 2. Okay, I'm using elimination method. So I will get 2a equals to 4 plus minus 2. So 4 plus minus 2. So you get 2. So a equals to 1. Now I can get my b. So b is, okay, so I'm using a plus b, right? So let's find 4 minus 1. I get 3. So I get my value. 1, a is 1, b is 3. Now I can find my equation of the curve. Okay, so equation of the curve. So go to this slide D here. All right, so now my D, I have dy dx is a is 2 x and plus 3 over x cubed, correct? Right, a is 2, sorry, a is 1, sorry, a is 1, b is 3, right? So original equation is a x plus b over x cubed, right? So we want to find what is y, okay? So can we ask yourself whether we can integrate straight away? All right, so this one cannot, right? So what we do, we have to simplify. So simplify. How to simplify? X over x cubed plus 3 over x negative 3. So you get x negative 2 plus 3 times x. Sorry, this one is positive 3. Then you got negative 3. So this is dy dx. Now I can find my y. Okay. So, so I will get y equals to x negative 2 plus 1 over negative 2 plus 1 plus 3 x negative 3 plus 1 over negative 3 plus 1 plus c. So I will get y equals to, this one is negative 2 plus 1 is negative 1. Therefore, I will get negative x negative 1 plus Okay, this is 3, right? This is negative 2. So therefore, it's negative 3 over 2 x to the power negative 2 plus c. So our y is negative 1 over x minus 3 over 2x squared plus c. So we are not complete yet, right? So we need to find what is c. So we go back to the question. So there's no very clear information for you. Just like C, it will tell you, okay, this curve passing through 4, 0, right? But here, there's no clear information for you, but you can find it from here, you see? The gradient of the curve at 1, 3 and negative 1, 5 is 4 and negative 2 respectively. That means we know that the curve passes through these 2 points, right? So there's 1, 3 and negative 1, 5. So we choose one of the point, okay? All right, so we choose 1, 3. Okay, so we put in, so this 3 equals to negative 1 over 1 minus 3 times 2, 1 square plus c, okay? So you get 3 equals to negative 1 minus 3 over 2 plus c. Therefore, c equals to, so negative 1 minus 3 over 2 is negative 5 over 2. Therefore, 3 plus 5 over 2, right? This part you get negative 5 over 2. So you move, you will get this, right? Then c equals to 2 times 3, 6. So plus 5, so 11 over 2. Hence, our equation will be y equals to negative 1 over x minus 3 over 2x squared plus 11 over 2. This is your answer. Right? You can try negative 1, 5. Okay, so let's try negative 1 and 5. Okay, 1 and 5. See whether it's correct or not. Negative 1 and 5. So 5 equals to negative 1 over negative 1 minus 3 times 2 over negative 1 square plus c. So you get 5. This one you get 1 minus 3 over 2 plus c. Right? Therefore, c is, this part is 1 minus 3 over 2. So it's 2 over 2 minus 3 over 2, you get a negative 1 over 2. So you move, you get 5 plus 1 over 2. So you get 2 plus 5, 2 times 5, 10, 10 plus 1, 11 over 2. So you get the same answer, minus 3 over 2. So x squared plus 11 over 2. So this is your answer for the question D, right? Okay, now we go to E. The gradient function of the curve passing through these 2 points. Okay, find the value of k. All right, so meaning that we need to use this to find the equation of the curve, then use this 0k to find the value of k, right? By substituting into the equation of the curve. So gradient function dy dx. Okay, let's use black. Is 3x squared minus 10x. So integrate both sides. Okay, so you integrate, you get y. Right, so this part. Okay, so you get 3x cubed over 3 square become cube. Then 10 minus x squared over 2 plus c. So you simplify, you get x cubed minus 5x squared plus c. So we want to get what is c, yeah? So we substitute negative 1 and 2 in. So you get 2 equals to negative 1 cube minus 5 times negative 1 square plus c. C you get 2, right? 2 minus 1 minus 5, right? Plus 5, right? So 2 minus 1, sorry, 2 plus 1 This one -5 times -1 squared is -5, so you plus 5. So you get C equals to 8. Okay. Okay. Therefore, I want to find my y. So my y is x cubed minus 5x squared plus 8. All right. So how to get the value of k? Okay, you can stop the video for a while, then you try by your own, right? So how to get? Put 0, k in. So I will get y equals to 8. Because when x equal to 0, y, okay, you do it by yourself, okay? All right, then the last example is this. The gradient function of point A curve at any point xy is given by x squared plus k. If the tangent to the curve at the point 3, 5 is parallel to the line y equal to 11x minus 5, show that k equals 2, equals to 2, and find the equation of the curve. So you can try this question, right, by pausing the video, right? You try first, okay? So, okay. So what should we do? So here the information, very important information is this. Tangent to the curve at 3 is parallel, right? So therefore, that's mean if I draw the curve, I simply draw a curve. So this is a tangent. So this tangent, okay, so this is y equal to mx plus c. So the the gradient here, the most important is the m, is parallel to y equals to 11x minus 5. Okay, so meaning here, you know that m is 11. So what is m for in term of gradient function? So it's dy dx. So if this is the curve y, right, fx. So the m must be dy dx. Okay, so now I can try to solve. So I have dy dx equals to 11. And then my equation, gradient of the function is x squared plus k equals to 11. Right, so I want to find k. So because it's a k is 2, so how to prove? So I substitute 3, 5 in, because at this point, only at this point, the m is parallel, is the same as 11. Because at this point, the tangent, that is y equal to mx plus c, is parallel to y equal to 11x plus minus 5. Okay, by the way, the tangent is an equation of straight line. Okay, so the tangent at this point, that is 3, 5. Okay, this is 3, 5. Okay, I definitely will know that is y equal to 11x plus c. So I can get my c when I substitute 3, 5 in. Right? So that one, we are not going to do that. That is in differentiation, right? So we just substitute the value 3, 5 here. So 3, we don't need 5, we only need 3. So that is 3 squared plus k equals to 11. So k equals to 11 minus 9. So k equals to 2. So proven, right? Proven. Okay. Hence, now we know that our dy dx is x squared plus 2. So it makes our life easier. So we just integrate. So we integrate. So you get y equals to x cubed over 3 plus 2x plus c. So to get my c, so I substitute back the same point, that is 3, 5, because we only know that 3, 5 is on the curve. So we put in 3, 5. So this 5 equals to 3 cube over 3 plus 2 times 3 plus c. So you get 5 equals to 3 cube. So we cancel, become 2. So 9 plus 6 equals 15. Therefore, c is sorry. Okay, hence our equation of straight line, sorry, curve is y equals to x cubed over 3 plus 2x minus 10. Okay, so this is our equation of the curve. Right, so you can see the method is still the same. You integrate, substitute the value in, you get the c, and then you rewrite everything, you get the equation of the curve. All right, so do self-practice 3.4 on page 91 and formative exercise 3.2 on page question 3 to question 8. Okay, so please watch this video. It's around 36 minutes. So after 36 minutes, you try to do. Then the second part of the after that 1 hour, I will discuss the exercise I gave to you, including this exercise. Okay.